Hello and welcome back to Calculus 2. We are starting chapter 10, and chapter 10 contains sequences and series. Some of you might have seen these before if you took the honors pre-calculus course, or if you took one of the honors courses on sequences and series that we offer, 1 credit. We are going to go in depth now. This is not going to be everything that mathematics has about these things, but we'll do the good chunk. So the entire the chapters 10 and 11 create these 3 groups of concepts that we focus on. So 10.1 and 10.2 talk about sequences, and then 10.3 to 10.6 will talk about series, and then chapter 11 will be power series. And all together they create this one unit that we talk about, and if you want we can have the exam 3 on it. One of your problems on the project involves this. If you pick that as a choice, you have 2 choices. So you have to submit 3 problems. There are 2 mandatory problems for everyone, and then there is another document which says choice, where you can pick a problem that contains sequences and series, which is involved with charging the battery. So this is computer science and electrical engineering. And the other project is about mechanics and so on. So that project would be that problem would be better suited for those of you that are going into mechanical fields and so on. So let's go and talk about sequence. So the first definition of the day is going to be, what is a sequence? Sequence is an ordered list of numbers. Emphasis on word ordered. You cannot walk up and just say 7, 1, 13, 153, and 29 and walk away. That's not ordered in any way, just a bunch of random numbers on a pile. The sequence is going to be ordered in some way through the set of natural counting numbers. Fibonacci sequence is is one of the yes. It will come up. It's a list of numbers. It's a list of numbers. It's not a procedure of any kind of operation. It's just a bunch of stuff. So here is the example. We use the roster form to list all of the values inside, and I say 2, 4, 6, 8, 10, 12. What's the next one? 14. Why did you say 14?
Because you're counting by 2.
Because you picked up the pattern. I'm counting by 2. So there is an order. If I ask you what's the next one, you will say 16, right? And I put 3 dots to emphasize that this is going to be going on forever. So this is a sequence. Now, where is the ordering here? Well, I have my first term. We'll call that A1. Then the second term A2. Then the next term A3. Then the next term A4, going on. Do we all see 1, 2, 3, 4, 5, right? So yes, that's an array. Very good. And which is a 1-dimensional array. Yes. And what I have here is clearly that an is equal to 2 times n as a formula. This formula will generate the entire sequence because the sequence is ordered through set of natural counting numbers n as the element of counting numbers set n, 1, 2, 3, 4, 5, 6, going on forever. You can also toss in 0 depending on the problem. So now I have a formula which would generate this particular sequence. When n is equal to 1, for my first value, my a1, see, when this n here is 1, then this n also has to become 1. So for a1, which is the first term, I will have 2 times 1, and that's 2. For the second term, my little n here is equal to 2, which means that the big N here, it's still lowercase n, is 2, and we have the second value, which is 4. Third term is 2 times 3 is equal to 6, and you can go as far as you want. Set of natural counting numbers is not bounded, it goes to infinity. So on the left is bounded because you start with either 0 or 1, and going to the right, it's going to go forever. Now, you get to come up with a formula that will generate your sequence. And you can literally put whatever you want, just make sure your denominator is not 0. So we can come up with an is equal to 2n plus n squared. That's fine. So what's my a1? It's going to be 2 times 1 plus 1 squared, which is 3. a2 is 2 times 2 plus 2 squared is 8.
You don't start at 0?
We can.
Well, so it doesn't matter.
Yeah, depending on the problem. It's specified.
Oh.
So, yeah. For computer science, it's hard-coded, right? You always have to start, and then you can, well, you can shift.
Index 0, but you can technically...
Well, that's hard-coded. Your index starts at 0, right? My index over here can start at 0 or at 1. I prefer 1 because 0 is not a counting number, right? If I am to count the number of students in a room, I'm not going to start with 0, 1, 2, 3. I'm going to start with 1, 2, 3, right? But I also understand that I could start with 0, right? But for computers, it's hard-coded to always start with 0, sorry, 0.
In an array.
Yes, in an array. So, guys, you can come up with anything as a formula. One more, an is equal to 2 to the n divided by, no coughing, 3n, right? So, what's a1? It's going to be 2 to the 1 times 3 times 1, which is 2/3. a2 is going to be 2 squared over 3 times 2, which is 4/6, which is 1/3. a3 is 2 cubed divided by 3 times 3, which is 8/9, and so on. You can generate this sequence all the way. So what do you get? You get that this sequence over here is equal to, in roster form, 2/3, 1/3, 8/9, going on to infinity. Recursion, yes, we get in recursion, and recursion gives you the Fibonacci sequence. So these are the sequences. The sequence is just the list of numbers, but it has to be ordered list of numbers, not just any list of numbers. Ordered list of numbers, and the ordering is done strictly to the counting set n. So you have to be able to find the pattern and make your sequence work. So here, this is going to be a challenge. Yeah, but not yet. So, yes.
Just explain what those symbols mean again. I was writing something down.
What symbols?
The N,
This? This is the counting n, which is our variable here. This one is the element of, means belongs to. And n with two lines on the left is the set of all natural counting numbers. All right, so now I have a question for you.
No.
We have an answer. Maybe.
That was the answer. The other day, we were watching video.
2, 5, 8, 11, 3 dots. What is the formula that would generate this sequence?
There's a 3 in there somewhere. Yeah, n plus 2. No, 3n.
No, so first time.
A to the 1 plus 3. There's a 3.
You gotta put in a z. No, wait, don't forget. 3n minus 1. 3n minus 1.
3n minus 1.
He's a freaking genius.
Would this work? Remember that your first n either starts with 0 or 1. Let's start with 1. So when n is equal to 1, for my A1 spot, 3 times 1 is 3, minus 1 is 2. Then 6 minus 1 is 5. 9 minus 1 is 8. Yeah, it works.
I told you there was a 3.
Yes, you have.
Yeah, you were real close.
Okay. I said A is a 1 and a 3.
How did you like scoop that?
I said A1. There's an A, there's a 1. This is different orders.
Ready?
Sure.
Yes.
2, negative 4, 6, negative 8, 10, negative 12.
If this is what the section is now, I'm in trouble.
You say that about every damn thing.
I know. I don't think this section.
Oh, you guys are funny.
That crime channel thing, whatever it's called, and they were talking about serial killers. And one of the twins, Jamaica, was listening to it. And he said, "What's a serial killer?" I said, "What do you think a serial killer is?" He said, "Somebody that kills you when you eat cereal." I started laughing. He said, "Somebody that kills you when you eat cereal." 2n minus minus? Oh, times. I think you're right. Look, I had 2 pens. Oh. No, because it makes it a negative.
This is negative.
No. That would make that positive.
It's squared.
That's it. It's n squared.
Oh, yeah, I see that.
Is it negative 2n minus 2?
Nope.
Hold on, it's A is 1. A is 1.
So we do that for all arts number and negative 2n for all one number.
Well, this is not a fair question because I didn't even show anything remotely. So, do we all agree on even numbers? 2, 4, 6, 8? All right. So, what is the way to denote all even numbers? 2n. So, we start with, leave some space. 2n, right? Now what I need to do is I need to alternate the sign on each one of these. So I'm going to multiply this by -1 to the n+1 or n-1. Okay, so now why is it this way? Well, think about it. This guy over here is just going to alternate the signs. That's its purpose. Its purpose is just to go positive, negative, positive, negative, positive, negative. That's all it does. And now remember this. If your first term where you're starting is 1, right? Then when you plug in 1 for this n, 1 plus 1 is 2, minus 1 squared is positive. So you're getting positive 2. Then the next time, so a1 is going to be -1, 1 plus 1, 2 times 1. And that's going to be 2. Now a2 is -1, 1 plus 2, 2 times 2. Now see, this is -1 to the third power.
You could have also done n modulo 2.
Yeah, but we don't have that now. Here. That's programming. So now it's -4. And going from there. So this is what we will call alternating sequence, because it alternates the sign. Later on, alternating series, which would be alternating signs. So you alternate sign with -1. Let me write that in blood. -1 to the n, -1 to the n+1. Those are the two. Now, if you really want to be fancy, right, you can achieve the same thing with the cosine n pi. That's the same thing. Cosine of pi, cosine of 2 pi, cosine of 3 pi, cosine of 4 pi. It goes 1, -1, 1, -1, 1, -1. Now that's the fancy one, right? This is the ones that we focus on. All right. So that's the alternating. One more to practice writing the formula by looking at the sequence. This is problem 30 in the book. We go with 64, 32, 16, 8, 4, going on forever.
No. What I'm going to do is that from now on, I'm not going to take the notes down. Because I take the notes out. When I take the notes, I'll rewatch it. So that way I can just listen to everything that he's saying. So that's more time.
You got it?
Even though we spend more time.
Alright, well, first thing we're doing is picking one. So, what formula is 1 we use 66? It could go, and then we find 1.
Put an 8 in there.
That's such a thing.
He's such a smart ass. Because it's an 8. No, but everything in there is divisible by 8.
4? Wait.
Well, 2 divided by 4 is 8. Kind of like a 4. What is it 2? Well, how do you figure that out? Is there a way to figure that out without trial and error?
No.
Are you serious?
Really?
There's no no way to do this, so you got to do trial and error. Oh, that's not mathematically correct.
It is. So, what do I need? I need to come up with the formula an equals to something, right? The first value, a1, needs to be equal to 64. And I need to come up with that 64 by using value of 1. So, if I go and I say 64 divided by n, just to try it, my first value over here is n equals to 1. Then 64 divided by 1 is 64, right? Then the n equals 2. 64 divided by 2 is 32. And then 64 divided by 3, it doesn't work, right? Do we all see that? It doesn't work. So it looked good for the first two terms, but then it failed on n equals to 3, and it's going to fail for every next one anyway. So this is not the way to do it. Okay, so that was a good first try. Then you go and you say, well, what else do I know? I see that each one of these is dropping down with the power of 2. It's 64 divided by 2, and then divided by 2, and divided by 2, and divided by 2. So what is 2 to the n? 2 to the n is 2 to the 1 is 2. 2 squared is 4. 2 to the cube to the 3 is 8. So a sequence 2 to the n is exactly what we have, but it's going the other way. So how can I use this knowledge? How can I use this knowledge to fit what I need for up there?
64 divided by
2 to the 7th minus n.
How did you figure that out?
Ask him, is right there. You don't need a middleman.
I'm not sure I know how to answer that. I did the same thing he did. I look at the pattern and I say, how did you get there? Yeah, but I
So that's all you. That's the only way to do these problems. Just like how do I get to the pattern? Oh, formula. There's no formula.
All right. So now, what is this teaching us in life?
Math sucks.
It's teaching us in life, right, to pay attention to patterns and practice, right?
That's what I said.
64 2 to the n. Can we do this? So when, but you have to start with n is equal to 0 in this case. No.
No, because 0 can be in the denominator.
Because if n is 1, you're going to get 32. That's wrong.
So, yeah, because you would start. So you have to start with 128 over, which is 2 to the 7th, which is, yes, minus n when you bring it up, yes. Because now 128.
It's a minus an n. Well, when I start with 0, then it's 1.
If you start with 0, yes. So if this is 64, and then you start with n equals to 0, then 64 divided by yes. So this could also be a solution, but you have to start with n equals to 0. This is another solution when n starts with 1. Perfect.
Oh. So where did you get the 7 exactly? What told him 7? Why didn't you use 5, 4, 2?
But 2 to the 5.
You gotta get the 64.
You have to make 1 more. So you need to go up 1 so I can subtract 1 and get 64.
Because the power, so this is 64, right? You have 2, 4, 8, 16, 32, 64. So this is your 2 to the 6, 2 to the 5, 2 to the 4, 2 cubed, 2 squared, going on, right? And it's going to turn into fractions, 1/2, 1/4, 1/8, 1/16. So when you look at all of these, you see that they're diminishing. So if you need to start with n equals 1, if you want to start with n equals 1, you can do it. Now, you can do 2 to the 6 minus n if you want to start with 0. It's also another way. Cool, huh? Why is this headache now? You're not used to this. You are not used to this. Now, have I done any integrals? Have I done any derivatives? Have I done any limits yet? None of that stuff, right?
Well, we're going to now.
Exactly. So, right? Now, before we go and do any limits and all these things, we have to also take a look at recurrence, which is recursion, yes? And these ones will be using the input to get the new one, right? So you get the previous ones to use the new one, to get the new one. For instance, your Fibonacci sequence is adding 2 numbers to get the next one. So you add 1 plus 1 is 2, and then 1 plus 2 is 3, right? So for recurrence, look at the Fibonacci sequence, and you have 1, 1, 2, 3, 5, 8, 13, 21, 34, going on forever. Every time I take the 2 numbers, I add them to get the next one. Then I add them to get the next one, and so on. 1 plus 1 is 2, and then 1 plus 2 is 3, and then 2 plus 3 is 5, and 3 plus 5 is 8. So what would be the sequence? Now we are going to say that A1 plus A2 is A3. Do we all agree on this? Your first value, your first number, plus the second number is the third number. Then you have A2 plus A3 is A4. A3 plus A4 is A5, going on. So do we all see that if you pick AN and you add to it AN plus 1, which is the next term, you will get AN plus 2? Do we all see that? Whatever your n is, let's say it's 3, then this one, if that was 3, 3 plus 1 is 4, and 3 plus 2 is 5. So this is the formula to generate Fibonacci sequence. Now, when you have recurrence equation, you also have to specify where you start. So I have to specify here, in order for this to be the original sequence, that A1 is equal to A2 is equal to 1, because I have to give that input as initial condition. Can I use this formula if I start the sequence with 3 and 7? Yeah, right? What's the next number? And what's the next number? And what's the next number? And what's the next number? So I can, right? What's the difference between this and the original one? Well, this one started with A1 is equal to 3 and A2 is equal to 7. So you can create these sequences with anything. Do I have to have this formula? No, right? I can come up with anything there. There's your computer science, right? I can say 2 times the input A1 plus 3 times the input A2 is going to give me the new value A3. Put the first input, A1, to be 0, and put A2 to be, let's say, whatever, 3. Doesn't matter. I'm picking random. So now, what's my sequence? Well, I have the first 2 listed, and now I need to create A3. I use the formula. Oh, crap. There we go. So now I plug in 0 for A, n. So that dies. 3 times 3 is 9. So this number is 9. Then I plug in 3 over here, I get 6. And 27. 27 plus 6 is 33. Next one. Plug in 9 in the first one, get 18. Plus 99 from the second one, right, is 117. And go on. So you can have any formula and you can start it anywhere for recurrence equations. And this is going to grow into some really cool stuff eventually in differential equations. So these are recurrence equations. And what is the recurrence? Meaning using the previous terms to generate a new term. I hope you see over here when we did this example, my number 8 never depended on 2 and 5 before. It doesn't depend on them at all, right? Because if I want to calculate what the third term is, I just go 3 times 3 minus 1 is 9 minus 1 is 8. I never used 2 and 5 to come up with 8. So those are the sequences, right, the vanilla ones. The recurrence one always uses previous input to generate the new one. Do you have to use 2 previous inputs? No. You can use 1, you can use 4, right? You can use any, depending on what formula you have, which allows us to have, right, variety of things that we can control and program, right? Mike will expand them if you have any questions. Well, you do this every day, exactly.
For fun? Well, you got it down, man. But this is how I look at integral calculation.
So now, ready or red pen?
Red pen.
Yes. So what are we going to do? We are going to write the test for convergence of a sequence. This is your first one, right? Test for convergence of sequence. And it goes like this. Take the limit of it. Limit as n goes to infinity of an is equal to, if it's a finite, we say it converges to L. If it's positive or negative infinity, we say diverges. Convergence. Do we all understand what that word means in English? Converge. Converge to a location, right? And diverge means, right? L is the limit as a finite number L. Like you get a number, yes. So, guys, these are the things that you will be memorizing.
That's one out of the 13.
That's one of the 13, yes, the first one, and the only one for sequences. If I ask you, is the sequence converging or divergent, you will just take the limit as n goes to infinity. What kind of calculation are you expecting? You are expecting 2.5 or 4.7 calculation, which means limits, right? L'Hopital rule. Or so let's take a look at this. I have a sequence, say an is equal to 3n minus 1. Does this converge or diverge? Well, that's why we have the test. So we go limit 3n minus 1 as n goes to infinity. What happens as you plug in infinity for n? It diverges. You're getting infinity here, so it diverges. This is the entire problem for 10 points.
Oh, damn. I got those too.
Yeah.
Yeah.
I didn't even have to spell it out all the way.
You plug it in. You plug in infinity. 3 times infinity.
See, this is my kind of math. I just memorize it and answer it.
So, most of this chapter is that.
Oh, good.
Now, see, this is the part where I said, if you learn this, it's going to be a joke. If you don't learn the box things, you're just going to, look at it and get nowhere. The test for convergence says you have some kind of sequence that is given to you as a formula an. The test says take the limit of it as n goes to infinity. If you get a finite value, it converges to that value. If you have the infinity of some kind, it diverges. So now what have we done? You have the formula an. You know that you have supposed to take the limit of an. Well, instead of an, you put the formula in. Do the Calculus2 limit, which you learned in 2.5, and then just claim from the test, because your answer was infinity, it diverges.
L will always be a number?
Yes.
It cannot be a function.
No, just numbers.
Okay.
So how about an is equal to 3 over 2 to the n, converge or diverge? Converge. Limit n goes to infinity. This is our test. Of 3 over 2 to the n is equal to what?
Very small number.
Which is 0. Yeah. Because you have a constant divided by a function that goes to infinity. So this is 0, and you say converges to 0. Now if you tell me, well, I don't remember limits, well, then there is no chapter 10 for you. You actually have to spend time. So the next class that we have is going to be on Tuesday, and we're going to cover another 2 or 3 tests, and they all have limits. The entire sheet over here are limits for tests, right? And the further and deeper that we go, ratio test and root test and so on, L'Hopital starts kicking in, like heavy kicking in. So this is where your weekend goes, practicing limits so that you can perform here. And I promise you the rest of this is going to be a joke for you. If you can take the limit and if you memorize which test goes where, it's going to be a joke.
But for some reason, I believe that you're oversimplifying this, aren't you? Because you're going to give us a sequence of numbers. We're going to have to find the...
Very good. Yes.
Then take the limit.
Exactly. Perfect. So you just, because that's exactly what I did over here. Didn't we have?
If you gotta just give us A and B or whatever you gotta do, and then it's like,
Hold on, you see that, look,
yeah.
right? We just did it in 2 steps, but that's exactly what we did, right?
He's going to give us a sequence.
It did look nice for a minute, didn't it?
How about we do a problem from homework?
That's a great idea.
Yes?
Is there any way to, like, because it looks like what you're going to have to do is like a lot of trial and error to find this, find that A equation.
To find an out of yes.
Is there like a series of like
Things that you need to, that you could memorize to speed up the process? The answer is yes. You memorize that your even numbers are 2 times n. You memorize that your alternating stuff is -1 to the n. You memorize that your sequence of values for a square, right, is 2, 4, 9, 16, right, the square numbers. You memorize 2 to the n, 2, 4, 8, 16, 32, 64, 128. So when you know those, right, then you get to, it is trial and error in the beginning, but then you start seeing the pattern, and the more you do it, the faster it goes. So you will be okay. Right now it's panic mode because you haven't done this before, which I understand, it's a panic mode. But as soon as you start hitting these problems and you say, okay, what do I have? I have 1, 3, 7, like 1, 3, 7, 15, 31. Like, what can you tell me about this? 1, 3, 7, 15. You are guys, you're getting it. It's
not 2 to the n plus 1?
You are so close. -1.
Why?
Because, look, you need to add 1 to each one of these. If you add 1 to each one of these, you make them into 2, 4, 8, 16, 32, which is your 2 to the n, but you added 1, so you have to subtract 1. And now, 2 to the n, if n is 1, 2 to the 1 is 2, -1 is 1. 2 squared is 4, -1 is 3. 2 cubed is 8, -1 is 7. Right? So you need to memorize these and recognize them. As I said, 2n, n squared, 2 to the n. You may want a 3n, n cubed, 3 to the n. And usually these are the ones that we bother you with, right? And now put them together in a fraction. Use 3n on top and use 2 to the n on the bottom, right? Shift 1 by 1 so you can put +1 or -1, right? It's when you do 10 or 15 of these problems, it's going to become very quick. Again, this is all new to you, so it looks terrible right now. Just give it a few homework examples and you should be fine. Should be fine. Then you practice to be fine. Now let's go back to testing our sequences. You requested something juicier, so here we go. How about sequence an, n squared over n squared minus 1? Converge or diverge? What?
Right.
Yeah.
So you have infinity over infinity.
Yeah, so
Which
you
is.
have to, that's the law of the top, and you gotta take the derivative of the top and the derivative of the bottom.
You're gonna have two.
That's a long way, but yes, you are correct. 100%.
So you have slightly less infinity on the bottom than you do.
Slightly lesser infinity on the bottom. Did I just hear that?
2n over 2n.
Technically.
It's gonna be 2n over 2n. And it's just gonna be 2 over 2. At the end, it's still 0 over 0.
No,
2
over 2 is 1.
Well, no, I mean, like, eventually you're gonna have no derivative.
You do it until you get numbers.
So that means it's,
Oh,
convergent.
because I was thinking, alright, now 2 is just gonna be 0.
No, I'm just saying convergent.
So yeah, it would be converged.
It would converge to what?
Converges.
To
1.
1.
Converges to 1.
Converges to 1. Okay.
Yeah.
Wow, we did it the long way.
Limit n goes to infinity of n squared over n squared minus 1. Now, you can either divide everywhere by n squared, which is what we teach in 2.5. You divide everywhere by the highest exponent, which is n squared. What you get is limit n goes to infinity of 1 divided by 1 minus 1 over n squared. When you divide 1 by infinity, that goes to 0. 1 divided by 1 is 1. So we say converges to 1.
So you have to say where it goes to?
Yeah, it has to be converges to 1. Now, if you use L'Hopital rule, perfect. I'm still happy, right? You have n squared divided by n squared minus 1. Using L'Hopital rule, you take the independent derivatives of numerator and denominator. So that's going to be 2n over 2n. And now that cancels down to 1 immediately, so you're done. No, you have to. You can't divide infinity by infinity.
Now this,
That's not allowed.
we did this before. Well, not the limit part, but the Fibonacci thing. Fibonacci.
So all this is based on taking derivatives.
Oh, this part.
Yeah, limits are derivatives. But you have, well, yeah.
Art, can you give us something juicy, like what would be on a test? Spicy, as you would say. In my country, we say juicy, we say spicy.
As you wish.
Alright. Let's see what you got now.
Oh, challenge.
No, I was challenging him.
How about an? There will be no square in this one. 2 to the n plus 1 times 3 to the negative n. Converge or diverge?
Diverge.
Let's see.
There's no quotient. It's not making it. No, don't make it no rule. Just plug infinity into the end. Plug infinity into the end.
How do you solve that?
Infinity plus 1 is just infinity. 3 to the negative 5. Oh, no. Yeah, see?
You weren't gonna do that.
That's where I was going, bro.
No, you weren't.
So algebra, right? Limit n goes to infinity of 2 to the n plus 1 divided by 3 to the n. Now, we peel off a 2. So this becomes 2 times 2 to the n over 3 to the n to get rid of that plus 1. Now, that becomes 2 in front of the limit, n goes to infinity of 2/3 to the n.
Why would you peel off that?
That's what I was
Because it's then times
2 to the n plus, it's algebra.
We're in calculus.
He got you there.
Or we can do the here's the algebra formula. This is the way you learned it in algebra. So that's how you peel off a 2.
Okay. That's all you have to say.
Oh, yeah. Yeah, don't take the water.
So now what's the limit here?
Oh, good luck.
What's the limit here?
Oh, you gotta be freaking serious.
What's the limit here?
Infinity.
No.
You're just plugging in infinity for n, right?
But there's a 2 in the front.
Well, let's just focus on this and we'll deal with it.
Yeah, that doesn't make a difference.
The 2 doesn't actually. What's in a box?
Oh my god.
0.
I said 0.
How is it 0?
I said 0.
So remember how you have e to the x and the graph looks like this? And then you have e to the negative x and the graph looks like that going to 0?
No, but okay.
So now e is a value that is bigger than 1. I know. I have 2/3. So if I flip this to come up with a 3/2, which is a number that is bigger than 1, then I would have negative 1 on top. So the limit of this would behave the same way, and it will drop down to 0. That's one of the ways. You can also use L'Hopital rule and other things.
And it is 2 times 0. Although I have 1 times 0.
So 3/2 to the n, as n goes to infinity would go to infinity, 3/2 to the negative n would go to 0. You can't have. Do what? 2/3. It takes time. That's why I said you have to review the limits. Otherwise, it's not going to be pretty. Yeah. Well, if this is tripping you, then the next one is not yet there. Yeah, let's give it a good old college try.
No, this one actually is pretty good.
Oh, this is good.
Damn it.
ln of sine 1 over n plus ln n.
Okay. What would you do?
I say it converges to one. Yeah. So ln and 0, that is 1. You don't have to take it. All you have to do is plug in. Plug in, yeah.
Sine of 0 is going to be 1. So ln 1, that's all. Sine of 0 is 1.
No, you're not taking ln. I mean, you're putting infinity in over n.
Okay, which gives you sine of 0, which is equal to 1.
Yeah, that's what I have.
Okay, so you have ln 1 plus ln. So now what do you get?
Ln to the infinity. I just put 0. And I said it converges to 1. I'm using logic. I don't know if it works.
He said don't use logic.
Well-
Now look at his face. His face is like absolutely
For
bad.
some reason, I don't know. I just.
We don't like the feeling over here. Let's use the formulas.
Okay, well, I kind of did.
Kind
So
of.
when you set up the problem as limit n approaches to infinity,
Yeah.
your next thing is to just plug in infinity and see where it takes you?
Yep.
Because that's where they're all at. So are they correct?
Going on a limb over there.
Well, isn't that what
Apparently
you
you
do?
guys aren't. No.
What do you do when you have addition of two ln's?
Okay, listen. I know the first step is write limit as n approaches to
multiply when
infinity
they
and
add.
rewrite the equation.
Yes.
What's my next step?
It's ln
There has to be like a step process. Step one
divided
is to
by b.
rewrite it like
I
that.
mean, x divided by y.
Okay. Now what's step 2?
Yeah.
Do I plug in infinity for all my n values?
Nope.
No,
We have this, so what now?
or multiply.
Multiply arguments, good.
Oh, yeah, and subtract is the thing. Subtract is the other thing.
For me, there has to be a step process. There's no step process.
So now what?
Ln of infinity. Ln of infinity.
But look, if you plug in infinity, sine of 1 over n is gonna be sine of 1 over over.
Sine of 0 is 0.
Yeah.
So it's gonna be 0.
So it's gonna be infinity times 0.
Yeah, so.
So that means it's 0.
To 0.
So at that point, you're
Infinity times 0 is 0.
Oh, wait.
Not always. Sometimes it's infinity, sometimes it's 3/2.
What?
You can go and watch one of my L'Hopital lectures. I have 0 times infinity. Sometimes it's 2/3, sometimes it's a quarter, sometimes it's infinity, sometimes it's 0.
Yeah, but this isn't a fraction. So how can you use L'Hopital?
You make one. But instead of making one, how about we use the oldest trick in a math book? And the oldest trick in a math book is, anyone?
Equal sides. I don't know, man. 'Cause I
both
just.
sides. There's only
U equals
Oh,
1 over n.
no.
Yes.
Why? Well, we were fine with zeros and ones.
Here is why. What happens here? You become ln of 1 over u sine u. And now this u over here is going to go to 0. If n goes to infinity, u has to go to 0. You use substitution. And then you have your limit. U goes to 0 of ln of sine u over u.
Wait, why are they supposed to go 1 over u? Why is it a 0? Oh, no, yeah, that's why.
So how much is sine of u over u as it goes to 0? 1.
And then you replace the n with 1 over there. You skip steps, you gotta try and figure out.
I didn't skip anything.
Well, okay.
Which step? I wrote them all down. This is not a derivative substitution, so there is no derivative. It's just u is just 1 over n, and if you write n, it's going to be 1 over u. So you can plug them in either way.
I'm still trying to figure out how you got ln and sine 1 over n.
That's the formula for ln's. You learned it this way. ln of ab is ln a plus ln b, or maybe xy.
Okay.
That was pre-calculus 1, chapter 3.3.
I don't remember pre-calculus 1.
Oh, I can see. So we use that formula.
It was a dark time in my life. I try to forget it.
To compress into a single ln.
Let's just say, for instance, you have this on the exam. And
What do you mean? Let's say this is on the exam.
okay, this
3 and final.
talking about this exact question.
Okay.
Okay. And you say converges
To 0.
But if you don't say to 0, but you know
It will make me very sad.
and you say it goes to 1 instead of 0, do you get the whole thing wrong?
Well, I mean, the whole thing is wrong because you have 1 instead of 0, but no, you don't.
So I'm just going to write down approaches converges at 1 and hope I'm get half points.
Well, I mean, technically, your choice is convergence or divergence, so your chances are 50-50, right? You can flip a coin on each problem, and we can calculate the chances. We can use Bernoulli trials to figure out the probability of flipping a coin on each problem. What's the right or pass rate?
I know I did it really wrong, but
No, but what I did was I took LM.
so when you have ln,
I mean, I feel like we just added extra steps, because that's what I said before, that it was converted to 0, but I feel like there was just extra steps added. Because I said it before you did those extra steps.
That's what I said. I said converges to 0.
And that was like 3 steps before you made
No.
Can't you just stop at a certain point?
That's what I put in.
what are you doing?
I just want to switch to homework.
27. Let's do 27. I don't know. He said it, not me.
I have no idea.
Where did that one? Yeah, we already did it.
All right.
We did this one.
Yes, we did. That's 21.
Well, there are the other ones.
Oh, yeah.
We do 61.
Why would you ever want to do something like that?
Because he's going to give us something like that.
I hope not. That's just
You
a
know.
dick move.
No, you definitely hope for 61.
I hope you give us something on the exam.
Just remember, this class is hard enough to
2x
begin with.
plus 3x is equal to, pick a number.
So, e to the negative n cosine n. Nice one. Nice pick. All right, we have the limit as n goes to infinity of e to the negative n times cosine n. You haven't done a limit like this in Calc 1, so you spotted it nicely. You probably don't know how to deal with this. What's the issue with the cosine? What is cosine doing? Exactly, right? The cosine is going to snake its way in. Now, what's the value of cosine at pi? You all know, it's -1. What's cosine value of cosine at pi over 4? Root 2 over 2, right? At any particular value that I ask you to, you can immediately give me the answer because, right, the limit is the y value at the point I'm asking. So, limit of cosine approaching pi, limit of cosine approaching pi over 2, limit of cosine approaching pi over 4, right? But now, what happens as the limit of cosine going to infinity, right? Does it stop at a value? No. Now, contain your brain. It has all of the values between -1 and 1. Now, how does that help us? It helps us because cosine is bounded by 1. It cannot be more than 1. And when you divide it by infinity, the answer is going to be 0. Right? You see, sine and cosine can be ignored in problems like this because they cannot exceed 1 or -1. So, when I am dividing, this is e to the n in the denominator, I can write this as a fraction. So, I can write it this way. Oops. So now, cosine n is bounded by 1. Cosine n being bounded by 1 means that you cannot get a bigger answer out of cosine other than 1. That's it. That's the largest. So, when you divide, the most it can be is 1. When you divide 1 by infinity, you get 0. When you divide -1 by infinity, you get 0. If you pick 0.2, divide by infinity, you get 0. Any value that cosine can spit out as the answer is going to be between -1 and 1, and all of them divided by 0 are going to give you 0. So, we have this equal to 0, and we say converges to 0. Excellent pick. Because cosine n is bounded by 1.
The same goes for sine.
Same goes for sine. So when you see cosine and sine in their vanilla form, cosine n, sine n, within the limit where n goes to infinity, you're dividing them by. Now, this would not be the case, obviously, if you had n sine n. I mean, in that case, that goes to infinity, and this is oscillating between 1, so in this case it would be infinity, right? It depends on what's there. Good. This is what the homework looks like. We're back to that page. So we did this problem here. We did this problem here. That one, that one, that one.
You explain 33.
Ooh, okay. Yes.
That is a factorial.
That is a factorial.
What the hell is a factorial?
That's an
Where do
explanation
you
of the point.
people come up with this stuff?
That's a factorial.
All right.
It's a freaking exclamation mark.
All right, guys. So this notation is called n factorial. It's not n, it's n factorial. You got excited, right? So what is the n factorial? Definition for n factorial is 1 times 2 times 3 times 4 times 5 times 6 times dot 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 times n minus 1 times n. You get to multiply all integers up to and including the number that you have in the factorial. So what is 5 factorial? Tell me.
5 times 4 times 6 times 2 times 1.
Yes. Which would be? 120. Good. That's what it is. So factorial is simply multiplying all of the values, all of the numbers. Now, there's some really cool things that you can do with this. N factorial can be written as n times n minus 1 factorial. You can peel off 1. Oh, thank you. Now I feel this. So now, also, we can have n minus 1 times n minus 2 factorial. Does this make sense? Well, hopefully. Let's go with the 7 factorial. 7 times 6 times 5 factorial. See, 5 factorial contains all of the 1 through 5, and then you have a 6, and you have a 7, for together to 7. Sometimes you need to peel off, right? And if you need to peel off, you have the lesser factorial following. Yes?
Is there a reason we haven't seen this so far in calculus?
Yes, because this is discrete. Factorials are discrete because there is no, well, there is, but 1.5 or 3/2 or, right? You have been dealing with continuous mathematics, right? When you say 1 over x, it's 1 over 1, 1 over 2, but it's also 1 over 1.5 and 1 over 1.15 and, right, anything else.
Like a irrational, whatever decimal.
Yeah. Yes, it is. In combinatorics. You learned it for Bernoulli trials. Combinations, things like that. All right. So now, why are we learning these factorials? Oh, you'll enjoy factorials. It's coming up for ratio test. So
In this class?
No, next one.
next week, yeah.
Okay.
But now, since they asked me about the limit of n plus 1 factorial over n factorial.
I have my notes from my statistics section.
Well,
I'm
that's
taking
good.
stat 2 on fun in the summer. For fun again.
For fun.
Yeah, I'm taking stat 2 for fun. I took it last
He
summer.
does stuff for fun, you do stuff
I
for
like
fun.
stats.
Apparently, I'm not on the ball game. Well, stats?
I like it because it's just like, it makes sense.
For me, it's like,
All right, so to find this, we can't do the limit with factorial, so we have to get rid of it. So I'm going to peel off the term that I don't need, which is n plus 1 term, and then I have n factorial over n factorial, and then they cancel, and the answer is infinity, so it diverges.
Yeah, right there.
N plus 1 is just the next term after n. So we peel that one off, the rest is n factorial, then they cancel, and you have just limit of n plus 1, when you plug in infinity, becomes infinity. Now all of that is the prelude to much nicer problem, which you will actually have to deal with a lot later in this chapter and chapter 11, and then differential equations. Here it is. Ready? 2n factorial times n squared divided by 2n plus 2 factorial. So the limit of this, you have to kill factorials. All right. So, limit n goes to infinity. There is nothing to do in the numerator. Oh, this is supposed to be n squared, not n factorial. Hold on. N squared. Divided by, now I gotta peel 2n plus 2. Then I get to peel 2n plus 1. And then I'm left with 2n factorial. And this is where these factorials cancel. And I'm left with basic Calc 1. N squared divided by 2n plus 2, 2n plus 1, which is clearly 1/4. Converges to 1/4. That's problem 34. Yeah.
So that factorial sign follows the same rules as like a normal variable.
It's not a variable.
Distribute that?
No.
No. Nope, 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 nope. The only rule we have is the rule to peel off stuff.
Okay.
How is it equal to 1?
1/4.
How is it
The top is n squared and the bottom is 4n squared. 2n times 2n is 4n, right?
But we have 2n plus 2 and 2n plus 1.
Oh, these things don't matter,
Yeah.
right?
Oh.
Because if you take when we start taking L'Hopital derivatives, they die before these guys die, right? So it's just coefficients of the, if they have the same power, it's just a coefficient of that power. Because you have 2n plus 2 over here on the factorial, so you start peeling, right? How are your numbers go? They go n minus 1, and then n plus 1, and then n plus 2, and then n plus 3, right? So if you're peeling off terms to get down to n, those are the ones that you kick out. As I said earlier, 7 factorial is 7 times 6 factorial. But you can also write 7 factorial as 7 times 6 times 5 factorial. If I need to peel off 2. 7 factorial is 7 times 6 times 5 times 4 factorial. If I need to peel off 3. So we peel off as much as we need. So I had to peel this much, which are 2 terms, in order for 2n factorial and 2n factorial to be the same, so I can cancel them.
That's a good question.
What is the question?
No, that's what I asked.
Yeah, I saw the question and just looked at it and was like, don't freaking start.
No, why doesn't it?
He's like,
He has no idea.
No, but you are matching them to cancel them. You see that I canceled 2n factorial?
I'm trying to go and get that.
how
But
do
I'm
you
saying,
get
say you were to
infinity
keep going.
squared is equal to 1?
You can keep going forever, but why would you?
I'm just saying, like, you know how you got 2.
I do know, but why would you? Because there is a purpose why you peel off to cancel, right?
So why is the 2 not being affected? Why is the 2n not being affected?
Which 2n?
Like, the 2n seems to stay each time.
Oh, you mean this?
Yeah.
Because it is, see, this is the next number when you put plus 1. 3 to 4, it's plus 1. 13 to 14, plus 1. 103 to 104, plus 1, right? So from here, this is the next number, and then this is the next number. Because you're just adding 1 and subtracting 1 to go one number up or down. That make sense? Good.
I still don't get it. This is the easiest part, I'm not getting it. Okay, I got it.
Can we do something without English in it?
Something without English in it.
Well, this is a math class. You can just start talking.
Oh, and this is wonderful. Okay. Oh my God. The easiest part I couldn't get.
It's too easy, not that. Yeah.
He almost had the answer.
Makes me laugh. Oh, he doesn't make me laugh.
Because he has this. He's looking at you like.
He's just like,
Oh, yeah, we got that.
All right. Last one, and then we have to go and talk about words. Yeah, definitions. Yeah. How about AN is inverse tangent then?
This is 1 over 1 plus x.
That's the derivative. I need a limit of it.
I just learned this today.
like an hour and a half ago. He comes here just to get maybe. I taught you that.
Nah, he's getting all the credit for it.
I'm going to say that this is I'm going to say this is going to go to infinity.
You haven't changed his guessing.
Yes. This is the inverse tangent, so it would be the opposite.
Now, back to this 1 over 1 plus x squared.
Okay. I said.
This is not 1 over 1 plus x squared. We're taking the limit. Yeah, alright, then I'm just going to plug in infinity for random.
That's what I did.
What do you get?
I got ready.
What the heck is inverse tangent of infinity? Inverse side.
Yes. See how that's okay.
Oh, God.
Kelly, what do you
Whoa.
She's lying. Clearly lying.
Oh my God.
Yeah, that's definitely wrong.
I still see it.
See how it's in my head though? 1 over 1 plus x squared?
Yeah, you just used it at the wrong time.
I got this. My brain is like a sponge.
Page is this one.
1 over 1 plus x
It's Larson book, it's not your book.
Excuse me?
It's not your textbook.
I have that.
You have it?
Yeah.
Depending on which edition you have, it's going to change the page. If you have the dark
You
blue,
told us in the beginning.
dark blue and it's the same one. All right. The answer is pi over 2, right?
How did you get that?
I memorized the graph for inverse tangent, and as you go to positive infinity, that was the only graph I said to memorize on day 1, and we used it 2 days ago or 3 days ago, right? 3 classes ago. So pi over 2. All right, so now what did we learn from all of these exercises that we have done? We learned that we forgot limits, right? So Time to begin. Again, if your education is over with Calc2, then you just need to make friends a little bit with this chapter in some way, shape, or form, right? And be done. Now, by show of hands, who's going to differential equations?
I mean, I'd like to, but I don't think I'm going to pass this on.
So, right? Anything that you learn halfway, don't learn well enough, eventually comes back and yeah, exactly, right, bites. So, these are the 3 sections in Calc 1. You can use the study plan to go back. You have all the steps when you're solving the problems because the limits. You can use all of the other software help that you guys have, and obviously stop by office hours. This Saturday, unfortunately, I have to cancel office hours because I have to perform family duties. But I'll be here next week, the entire week, right?
Office hours on Mondays, right?
Yes, and Tuesday and Thursday.
What time is it on Monday?
I don't know, ask people.
Ask people. Is anybody on? Look on the syllabus. Great idea.
Exactly. I provide. Oh yeah. No, you have the correct office hours on the syllabus.
Oh,
What you don't have is just the correct order of sections in the back. Your entire syllabus is valid, other than the last page.
Oh.
Entire syllabus is valid other than the last page.
Monday, 7:30 to 8:30. Yeah.
That's a lie. It's 7:35, 7:40, because my class ends at 7:35 in West Building, and then I need time to teleport.
So the syllabus isn't correct.
Yeah, 5 minutes off,
Oh, okay.
10 minutes off. On one day. The others are correct.
That's like them DXs, -1, man.
Sure, guys, here.
7:30 p.m.
No, okay. Why was it pi over 2 again? Oh, because that's what it's bound by.
Yes, very
Remember
good.
that
Found.
graph.
Yeah, I know. That's the one he gave us in the beginning of the class.
All right. Are we ready now to go and talk about important formulas, important definitions, so we know what the words mean as you go through these problems? The first thing that we are going to the sequence. Well, before we, right, so let's see what all of this stuff means in terms of graphs and stuff. So now we understand that the sequence is the list of ordered numbers. Ordering is done through natural numbers n. We also understand that the formulas are related to the sequence, so you can get a formula, write a sequence. You can get a sequence, write a formula by trial and error, practice, right? And then finally we learn the test. If the limit as n goes to infinity is a finite number, like we had in the past, we had pi over 2, we had 0, then we say it's convergent to that value. If you get infinity, it's divergent. What are the other things that we have to work on? Well, how about just, what is this thing actually, right? So if you have an is equal to 2n minus 1, you can write the sequence as when n is equal to 1, right? Start at n is equal to 1. If n is equal to 1, the first value is 1. Then the next value is, when n is equal to 2, is 3, 5, 7, 9, 11, 13, and so on towards the infinity. 2n minus 1 is the way to write odd numbers, right? 2n is for even, 2n minus 1 is for odd. So, can I graph this? And the answer is obviously yes. Your input is the n, which is 1, 2, 3, 4, 5, 6, and so on. There is nothing in between these numbers. These are discrete jumps from 1 to 2. What you need to think of? An egg. You go to the store, you buy a dozen eggs. You go to a store that has more choices, you're able to pick up 6 eggs, right? Half a dozen. Maybe you can convince them to sell you 1 egg, right? If you're vocal enough and just want to get rid of you, right? Can you buy half egg? No, you cannot buy half of an egg. So these are discrete jumps. So this value here is A1. It represents n equals 1. And if I go 1, 2, 3, 4 like this, then all I have is a dot at 1, 1. For 2, I have to have a dot at 3. For 3, I have to have dot at 5, at 4, dot at 9, at 7, and so on. I don't get to connect these. These are discrete dots. This is not 2x minus 1. What's 2x minus 1? 2x minus 1 is going to be a line. What's 2n minus 1? Series of dots. They are going actually through the same location in space. X's are continuous. N's are discrete. You do not get to connect these. This is what it is. It's just a series of dots. So, anytime you have a sequence, the graph for that sequence is going to be series of dots. Now, the series of dots will have tendency to converge or diverge, converge to a horizontal line, which is actually the limit that you are looking for. So I can show a few of these graphs that are beautifully done in a book. Here's one. What do I have here as a sequence? As a sequence, I have n over n plus 1. N over n plus 1, you take the limit, you take the L'Hopital, infinity over infinity, is n over n, which is 1. So you can see that your sequence of dots is approaching 1. The first red dot is above 1. The next red dot is above 2. Now, why do they have the black line through it? Because in black, they have a comparison function from your previous life of continuous functions, x over x plus 1. So they follow the same path, but the world of continuous, what you did so far, and the world of discrete, which is now new and red in this graph, right, are not the same world. You can find area under the black line because it contains area under it. You can't find area under the dots, right? Links everywhere. There is some special called Lebesgue integration that you learn when you take 700 level courses, right, in math. But for our purposes in calculus, right, you don't get to integrate this chapter because it's not a continuous function. We are going to have integral test, but we only think that we will constantly use limits, 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 limits in every problem, occasionally derivative, occasionally integral. Limits 99% of the time, and every problem you see. Limit, 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 all the time. So now that we understand, let's find more of these. There we go. More examples. The one that you see on top over there with the black and red dots is the alternating sequence. You have a black dot, move a little bit to the right, you're going to run into a red dot, move a little bit to the right, you go a black dot, So black, red, black, red, black, red, black, red. And what they do is they, from two sides, they go and they hug the limit, right, the value. So this is alternating sequence. Now, it's going to be, this is actually, I can enlarge this. Give me a second. So when I enlarge this graph, now what I can do is I can make the folder. Look at this. This first number over here is 1, and then when you move 1 in, it hits the red dot, and then you move 1 in and it hits the black dot, and then you move 1 in and it hits the red dot, and it hits, right? And as you keep moving in, it keeps alternating between the values. You get one and then the other, and then the one keeps jumping. Okay, what else? Here's more of these convergent to 1. Here's the one that converges to 0. Here's another alternating. You see that? The dots jump here, 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 right? They go like that, and they converge to 0 in infinity. In infinity, they converge to 0. Here are your divergent ones. They don't settle as they go to the right. They do not settle on a line, on a horizontal line. They shoot to infinity, and these two go apart, right? So that's what divergent is. And we go from, we would say that the ones that converge, they're bounded because they don't go past certain value. And one that are divergent, they're unbounded because they shoot to infinity. Right? Yes?
Wouldn't that also be based on how you're reading it? So if you're reading towards the...
No, you always read to the right.
Always.
Yep. It's not Arabic. Okay.
Can you open the homework for this tonight?
Yes.
She's gonna open all the
Please.
homework. Even the
We are
one
going to
you
need
missed.
as much practice as possible.
Yes.
Just do the study plan.
So you can do that.
Are you ready?
No, but
Sure.
let's do it.
Let's go. Do we all understand the concept of an increasing sequence?
Keeps increasing.
So increasing sequence, the formula is an plus 1 bigger than an. So any term that you pick is strictly bigger than the term before. So there will be no flat pieces to go from 3 to a 3 and then to a 4. It's going to be 1 to 2 to 3 to 4, or 1 to 5 to 7 to 19, right? It always increases. Ready for the next one? Non-decreasing sequence. Now, before you scream, can we just call this increasing? No. Because this one allows for the values to be the same between the two consecutive terms. Then we have decreasing sequence. An plus 1 is less than an. And then non-increasing sequence, an plus 1 less or equal than an. Next word, monotonic sequence. Is if the sequence is either non-decreasing or non-increasing, then it's called monotonic.
Neither or either?
Either. So all non-decreasing and all non-increasing sequences are just called monotonic. And then finally bounded. So you can think of a bounded one as the one that converges from above or below. So bounded from above or below, or both. Inverse tangent. Bounded from the bottom minus pi over 2 and bounded on the top by pi over 2. So it can be both. Sequence that is bounded above is the one that rises and then has a cap. The one that is bounded from below would be when it goes downwards and then it hits the bottom. And if it's bounded from both sides, we just call it bounded. Increasing, non-decreasing, and decreasing, non-increasing, monotonic, bounded above, bounded below, and bounded. So those are the words. Now the more stuff with the geometric and arithmetic sequences, but since we have our tests to be that, so we don't have to worry about it. We're just gonna jump into the next section, which is very short, and deal with that after the short break. See ya in 2 minutes.